Hey people, and welcome to this video. In this video, we are going to be working on the Senior Certificate Mathematics Paper 2, and this is for May-June 2025. Okay, so same as usual, it's 150 marks and 3 hours. And we can see the instructions, and we move on to question 1. Now, before we begin, just because these questions have been coming up in the comments, guys, remember this is not if you're in grade 12, this is not the paper that you're going to write. This is the senior certificate paper. So if you signed up to write at the beginning of the year, then this is the May-June exam that you will write, okay? And it has already been written. Now, in my opinion, and opinion of many people, honestly, this paper is usually much more challenging than the November paper, so it's a very good reference to use when practicing for June and also, prelims and November. Okay, so with that being said, let's get into this video. So we have question 1, and question 1 says, an insurance broker signed contracts with 15 people. The monthly premium in rands payable on each contract is given below. Okay, so these are the monthly premiums. Okay, so it's 134 rand, 215 rand. So they're all in rands. Just keep that in mind. So the first question is to calculate the mean of the data. Okay, so to calculate the mean of the data, you know the drill by now. You can use your calculator to do this. So on your calculator, you're going to press the button mode and you will see some options. You need to go for the option that says stat. And then you're going to go for the option that says variable, VAR, because right now we only have a one variable data set. So my calculator is over here. And then we are going to go ahead and put in these values. Okay, and then once you have the data, you're going to press AC, then Shift and 1. Okay, and with that, you're going to go for option 4, which says VAR. And then remember, we are looking for the mean. So we go for option 2 with the mean value. So you can see that our mean is 570 points, and that rounds up to 27. Okay, so that is the mean amount. In rands, these people are paying this amount, okay, on average. Okay, so that is it for 1.1. Moving on to the next question. The next question says, write the standard. So write down the standard deviation of the data. So we're going to find the standard deviation in the same place that we found the mean. So on your calculator, you can press Shift and 1. It's perfectly fine. I have to remove that first. And then go for VAR. And then you'll find the standard deviation at option 3, and it'll look like that. So let's see the standard deviation. Now we can see that the standard deviation is how much rands? It's 291.03. Okay, so 0.3 cents. And that is our answer. Moving on to the next question. The next question, 1.3, says, calculate how many monthly premiums are within one standard deviation of the mean. Please notice they say within. Okay, so when we are looking at the amount of numbers that we have, or the values that are going to be within one standard deviation of the mean, you can think about it like this. So because they have to be within, it means they will be within two values. Okay, we're going to look for the numbers that are between these two values. And how we find these values are like this. It's one standard deviation of the mean. So we're going to be looking at the mean, and it's like if the mean was over here, you're moving one standard deviation ahead of the mean. So you're going from mean and you're adding a standard deviation. But then this would not only be the only way to find one standard deviation from the mean. So we just moved ahead a standard deviation from the mean. You could also move behind. So that would be where we'll say the mean minus the standard deviation. So that's how we're going to get those two numbers. We'll have to say the mean minus the standard deviation and the mean plus a standard deviation. That would be exactly one standard deviation from the mean. Okay, so let's go ahead and find out what that gives us. If we say the mean and minus the standard deviation, what do we get? Okay, so we're going to say the mean. We can just use these values that we already have. So 570, 27 minus 291.03. And then that gives us 279.24, and then a standard deviation plus the mean. So we're just going to change that to a plus, and we get 861.3, which we can just leave as 30. Okay, so these are the numbers we're looking at. So what you're really looking for is, it's kind of like looking at these on a number line. And on that number line, you have the number 279.24, and then the highest one is 861.30. And you're just looking for all the numbers that fall within these two. Okay, so greater than this, but less than that. So let's go ahead and look for those. Okay, so looking for these in the data set that we have, let's go ahead and count how many numbers we have here. Okay, so 134. You see that this would fall behind 279, so that is not included. 215, also too small. Okay, that's 7, so no. What about 325? And you can see that they already put this in ascending order, so we don't have to overthink things. Okay, 325, yes, that falls within numbers that are greater than 279. So that comes with, that will also be in. These will also all fall within one standard deviation of the mean until this. And then you see 923 is bigger than this, so it will fall here. So that's not within a standard deviation of the mean. Okay, so how many values are those? Well, the ones we know, it's 15 people in total. So the ones that are not included are 5. So it means these are 10. Okay, and remember the question was calculate how many monthly premiums, okay, are within that. So these are 10 monthly premiums. Okay, so that is it for 1.3, and moving on to 1.4. Okay, the next question and the last question for question 1 says, the insurance company decides to increase the monthly premiums. Okay, so the monthly premiums that were less than 500 Rand increased by 18%. So we're going to have to look for those. And then the monthly premiums that were equal to or more than 500 Rand increased by K%. Okay, so you see that we have these split into two categories. It can either be less than 500 or equal to or greater than 500. Okay, so that increased by K%. And what they say is, after these increases were applied to the above data, the new mean monthly premium was 686.44. Calculate the value of K. Okay, let's go ahead and brainstorm this. So you see that we have two categories. Okay, we have values that are where the premium is going to be less than 500 Rand, and we have the ones where the premium is going to either be equal to or greater, so greater than or equal to 500 Rand. So this one increased by 18%, that one increases by K%. So the first thing to do is to find out which numbers these are. What are the premiums less than 500 and the ones that are greater than or equal to 500? Okay, so let's go ahead and mark the ones that are less than 500 Rand in red and the ones greater than 500 in blue. So less than 500 would be all of these, as long as you don't see 500. Okay, there's the 500, so these would be greater than 500. And it's all of that. Okay, so you can see that it is 3, 6, it's 6 of them that are less, and the remaining 9 would be greater. So let's go ahead and take this down so we can work with it better. Okay, so we know that these ones, they are going to increase by 18%. And these ones are going to increase by K%. Okay, and we have to find out what K is. So let's think about how we can actually create some sort of equation to solve for K, to solve for this problem. So we had the mean of this before, but now the thing is these prices have increased. This increases by 18% and that by K%. But then when put together, when they are added together, the final mean amount we have is this. So how we can formulate an equation to solve for this would be like this. So we need to first show that these ones increase by 18%. So think about increasing something by a percent like this. You can think about it like this. For example, you can add all of these numbers together, and when you get the amount, right? When you get that amount, you can either say this and then multiply by 18% and then get your number, then say the original amount plus that increase, and it'll give you the increased amount. Or another way to do this, because these are already numbers, is you could have just said whatever amount they add up to, and you can say multiply by 1.18. Because 0.18 represents 18%. So 1.18 would be the amount, the sum of all of these, plus an additional 18%. So that would be the 18% increase. And that's what we can go with. We can go with that. So let's go ahead and add these amounts. So we'll find the sum of it first, and let's see what that gives us. And you see that the sum of it gives us 1,791. So this is the amount that will increase by 18%. We should also add these ones up because it's going to be helpful. So let's add that up as well. And you see the sum of that gives us 6,763. Okay, so here is how we can actually create this equation. We know that this is just the sum of the values. It's not the average, okay? So the entire average is over 15 since we have 15 values. So what we can do is show the increase here first. And by showing the increase, what we're going to do, because this one is already a number, we can just say 1791 and then increase it by 18% by multiplying it by 1.18. So that will increase it. So this is a calculation on its own first. And then we will add it to this amount because they are still part of a whole of the 15 values. But we're just going to calculate their increases separately since they're increasing by two different percentages. So with this one, because it's increasing by a variable, I'll be careful. And instead of saying times, 1.k%, because I don't know what k is, here is how we can do this. We can actually work with this one the way we would increase something if you were increasing it gradually. So we're going to put down the sum of the amounts, which is 6763. And then account for the increase that's going to happen. So it's this amount and then 6763 multiplied by whatever increase that is, which is k%. But because this is a percentage, you see how we were able to convert 18% to 0.18? We can do the same thing for k by putting it over 100. Okay, 0.18 is the same thing as 18 over 100. So that's how we can calculate that increase so that it doesn't confuse anything. We can still see exactly where the k is, and whatever k gives us, that is the percentage increase. Now, right now, these are not averages, okay, because we really just added that amount. It's not an average yet, okay. The amount that they gave us here, this is the new mean amount. So this is already an average, meaning this amount was found by adding all of these up together, of course, taking into account their increases and then dividing them by 15 since we have 15 values. That's how we got that. So we're going to have to do the same thing here. We've added these amounts together and then you're going to have to divide them by 15 to get the average. And we're saying it's equal to that average amount, which is 686.44. So we'll put that amount there. Okay, so this is what our equation looks like, and all we have to do is solve for k. Okay, so let's go ahead and we can already right away start by getting rid of the 15 on the denominator. So to do that, you would multiply both hand sides of your equation by 15. Okay, so we'll say times by 15 here and times by 15 here. And so this 15 will cancel that out. And all you're left with is everything in here. I might as well take the opportunity to multiply these two together. So let's find out what that is. So that gives us 2,113 0.38. And you see there's no need for a bracket really, because these were just multiplying and then there's an addition. So we can just go plus and find out what this is. This is just going to still be the 6763 plus, and then these two multiply. Okay, so long what we can just do is, because these two are multiplying, you can see this as if it is on the numerator. It has a natural denominator of 1, so numerator times numerator and denominator. Or we can just rewrite it like this. So 6763 over 100, and then just put k as the variable. Okay, and now that is the calculation we have to do. So let's find out what that is times 15. Okay, and the amount we get here is, we're going to put down 1029.6, which is really 60. I'm just leaving them as 2 decimals. Okay, so that's what we have. And now you see that to get closer to k, you need to get rid of these, okay, because they can add together. So let's just add them together and then get rid of it. And together they give us 8,876.38, and you still have this. Well, it can divide by, you might as well divide it by 100. So 6763 divided by 100 gives us, okay, it's a nice looking decimal. So 67.63 and then k, and then our answer, of course. Okay, so at this point, you see that this has to be left alone since it has the k. So we should get rid of that. So we can you can see it as taking this over, or really subtracting both hand sides by 8876.38. So we'll subtract that on both sides and we get closer to that k value. Okay, and guys, I just realized I've been writing that number wrong. Okay, it's not 1,000, can't be 1,000. It's 10,296.60 cents. That's how much we have there. Okay, and then we will subtract. When we subtract that, you see we're going to get 1,420. Okay, 1,420.22. And here, these cancel. So you're left with the 67.63k. That's what we'll be left with here. And then to solve for k, finally, we're just going to divide both hand sides by 67.63, and that will give us our answer for k. Okay, so that therefore means that k is just equal to, now whatever answer it gives us, we're going to take it like that. So if you divide that by 67.63, you get 20 point, and that's 99. Okay, so you see what happens if it's 9998, it's going to round up. So round it off to 2 decimal places, it's going to round that up, and then it's going to add a 1 here and then add a 1 here. So at the end of the day, k is finally just equal to 21%. Okay, so that is what it is. So that's what I meant by k is going to be whatever it is. We won't even have to divide it by 100 because we already put it over 100. Okay, so k is equal to 21%. And now we know what exactly those values increase by. Okay, so that is it for question 1. And we move on to question 2. Question 2 says, the manager of a supermarket decided to do a survey on the number of items that a customer ordered online and the time in minutes that a packer took to have the order ready for delivery. Okay, let's do something here quickly, okay? Because the thing is, they don't always give you this. So notice that I removed that table because I want you to be able to see your 2 variables here. Okay, sometimes they don't actually give you the variables. They don't tell you this is X and this is Y. So you need to be able to see it from the context. So this manager of this supermarket is doing a survey on the number of items, right, that a customer ordered online. So you can see this is one of the variables. Items that the customer ordered online and the time in minutes that a packer took to have them ready for delivery. So one is the items, the other is the time. Then, of course, they tell us the supermarket received 10 online orders on a certain day. So you can already see from this information, because the things that are being measured or monitored are the amount of items that were ordered online and the time that it took to pack these orders. You can see that this manager is trying to find out if The amount of items order affects the amount of time it will take to pack the order, which is, it definitely affects it. So the more items that you have ordered would obviously take more time to pack it. So since you can see that the items is actually what affects the time, this would make these the x values and that the y values, because the x values are known as independent variables. They can be anything. And then the y values will be known as the dependent variables because they are whatever they are depending on what x is. Okay, so let's get the info back. So we are given a bivariate data set and they want us to draw a scatter plot on the grid provided in the answer book. Okay, I don't have the grid, so I'm just going to draw out this graph. So when you are drawing them out, remember these are your x values, these are your y values. Make sure you choose values that are more suitable, increments really, what you're counting in. Choose those numbers based on what would suit these values. So with these, I'm just going to count in twos because they just seem like they would go better with these values. And I also just go with twos here. Okay, and then just give us a name relevant to the survey. Say time taken to pack online orders. Okay, so this is what we have. And now we have to plot it down. So remember, these have x and y values. So for example, let me just actually make this like that. So when you're looking at these values, we are taking this as an x value. So that is 10. So you go to where you see 10, and then you can see that the y value for that is 5. So it's like 10. And then 5 is somewhere over here, okay? And then we have 3 and 5. So you're going to go to where you see 3, which would be between 2 and 4. And then the y value is 5 again. So make sure it's in line with this. Of course, on the grid paper, it's going to be so much better. And again, 20 and 9. Okay, so 20. And then 9 is somewhere here, okay? And what we will just do is plot down everything. And just for reference, just in case they ask those types of questions, I'm going to also put down their coordinates. So for example, this one, because the x coordinate is 3 and the y coordinate was 5, I'll put it down like that. Okay, so that was this one, 3 and 5. So let's just fill that up and then we can move on. Okay, so there. And that's what they asked for. They said just draw a scatter plot on the grid provided, and there's our scatter plot. Okay, so you see how these values are. You see what they're generally doing, how they are moving. They're moving upwards. Okay, so that's just another thing to see the trend. So your correlation in this case will be a positive value. Okay, moving on to the next question. Okay, so the next question, 2.2, asks us to determine the equation of the least squares regression line. So we're going to have to use these data values to do that. Okay, so just remember that the equation of the least squares regression line is y equals a plus bx. So all we're looking for is the value of a and the value of b. Okay, let's go ahead and find that. So on your calculator, you're going to have to put these values down. So you can exit. In fact, you can go back on comp, right? Complex, and then press mode and then stat again. But this time, instead of going for number 1 VAR, the single variable data, you're going to go for a plus bx because we have bivariate data. So go for that. Okay, mine is over here by data. And then, yeah, I still have values here. I still have to remove it. Whatever past exam paper I did, it's always going to still be here on this calculator. Just keeps it recorded. So let's go ahead and just put these values, put these ones in x and these ones in y. Okay, so we have these values recorded. And then again, you're going to press AC, Shift, and 1, and you're going to see some options. But this time, you're going to go for the option that speaks about regression. So that's going to be option 5 for you guys. And then we're going to go for the options that we can see. So remember, we're just looking for A and B. So A, first of all, is 3.0. And you see that's going to round up, making that an 8. So 3.08. And then you can press Shift 1 again. And then you're still going to have to go for option 5 for regression. Then B is equal to 0.35. And now we can just fill this in the equation. So therefore, it means that y is equal to 3.08 plus 0.35x. And that is the equation of our least squares regression line. Moving on to the next question. The next question, 2.3, just asks us to write down the correlation coefficient of the data. It doesn't really say anything about, tell us about the strength. Okay, comment on the strength. So we're just going to find that. So press shift 1, again go for option 5, and then go for option 3 for correlation coefficient. And you see that our correlation coefficient is just 0.74, rounded off to 2 decimal places. Moving on to the next question. The next question, 2.4, says, the supermarket receives an online order for 13 items. Predict how long in minutes it will take a packer to pack the order and have it ready for delivery. So do you see what they are referring to? They say they received an order for 13 items. If they're giving us the items, you need to see which variable this is in our data. The items are the X values. So they've given us an X value and we need to find a Y value. So predict how long in time. We know that the time is the Y. So we can use the equation of the least squares regression line for this. We're just going to simply substitute the value they gave us for X and it will help us to find the Y value. So Y is equal to 3.08 plus 0.35, and in place of X, we're going to substitute 13. Okay, your calculator can still calculate even when it's in that mode. And you see that the Y value is 7.63. And remember, this is the time in minutes. So you can just say 7.63 minutes, and that's fine. Okay, moving on to the next question. The next question, and the last question for question 2, says, explain why the y-intercept of the least squares regression line in question 2.2 does not make sense in this context. Okay, so in statistics, values mean certain things depending on the context. So the question here is, why does a y-intercept not make sense? Let's think about that. A y-intercept is a point that intersects the what axis? The y-axis. So let's say we had a y-intercept like somewhere over here. Why would this value not make any sense? Well, if you look at that, it means that your y value is 2. And I just realized I didn't even put a y value here. We need to label that. So I erased it in the process. Okay, I'll put that back. Okay, so remember that is the time in minutes. So why does this not make any sense? So if this point is at 2, what does that mean? Well, at this point, the y value is 2, meaning the time, right, would be 2. It's not really that amount, but it's actually this amount over here. That's the y-intercept. So it's 3.08. Okay, so maybe somewhere here. So why would that not make any sense? Well, because the time, sure, it's 3.08, but it would mean that the number of items packed would be 0. That doesn't make any sense. Remember that in this survey, this manager is recording the amount of items that are being packed, right? And how long it takes. So the only things that are going to go down here are items that are packed. If there are no items packed, the manager is not going to record anything. Okay, so that is why it doesn't make any sense. So we just have to put that in words. So we can just focus on the fact that the y-intercept would represent the time where 0 items are packed, okay? Or even ordered, when 0 items are ordered. And this will not make sense, of course, because if there's no order, then there's no time to be recorded. And so this will not be added to this table. Okay, so the y-intercept represents the time taken when 0 items are ordered. So this doesn't make sense, as no orders would be recorded if no items were ordered. So no time would be measured. Okay, so it simply doesn't make sense because he's only recording when an order comes in. So no order, meaning no time to record. Okay, so that is it for statistics, and I will see you guys in analytical geometry.